Hi guys, today I will be telling you why government agencies and companies are preparing to go to Mars, using the moon as a testing ground. Mars is a long-term destination, and today we will be going through historical and current missions to the Red Planet, where we have sent landers, rovers and robots to Mars, and made discoveries that have given us a reason to want to one day settle humanity there. So what have we learned by landing on Mars? We as humanity have sent many missions to Mars, but only a few have been successful. So let's get into it. So the first successful missions to Mars were Mariner 4, 6, 7 and 9 from 1964 to 1971. NASA's Mariner 4 was a flyby mission, the first spacecraft to reach Mars successfully, and it took the first close-up image of Mars with its telescope. It discovered the Martian atmosphere is much thinner than expected. It did not detect a magnetic field, radiation belt or surface water. It was followed by Mariner 6 and 7. All of these missions sent back dozens of photos of the Martian planet. It found that the Mars atmosphere is mainly carbon dioxide and found trace amounts of water on the Martian surface, giving us hope for life. But the most notable Mariner mission was Mariner 9. You see, when Mariner 9 arrived, the entire planet was covered by a dust storm. When the storm settled, scientists discovered the tops of dormant volcanoes and the Valles Marineris. Now, there were many other countries sending spacecraft to Mars, and most failed, but the USSR managed to send Mars 2, 3 and 5, which reached orbit but only lasted a short amount of time. In 1975, NASA sent a pair of orbiters and landers, Viking 1 and 2. Now, the orbiters orbited the Red Planet, hence the name, and the landers landed on the surface. Now, one of the goals to land on Mars was to find life. However, they didn't find or prove any existence of microbes, but what they did find was that the meteorites that we have on Earth have actually come from Mars, and this is because they are almost identical to the ones on the Red Planet. The lander also discovered that the Martian soil is predominantly iron-rich clay. Then there was the Mars Global Surveyor. Arriving on Mars in 1997, this craft gave us a map of the Red Planet from pole to pole. It revealed ancient signs of water, such as gullies formed by flowing water and a mineral that forms in water called hematite. The new deposits found in some gullies have given us evidence that water still occasionally flows on the Red Planet. Then we have the resilient Pathfinder lander and Sojourner rover. Arriving on Mars in July 1997, only expected to last a month, but instead remaining in operation till September 1997. Sojourner was the first moving vehicle to be used on Mars. Now, I'm going to highlight a mission failure that happened shortly after 1999, and NASA and the world learned a big lesson from this. So the Mars Climate Observer disintegrated in the Martian atmosphere, and that's because all the calculations were not converted from English units to metric units when directing the spacecraft into orbit, which led to its failure and is quite well known as a mistake that probably shouldn't have been made. However, moving on to a big success, we have the Mars Odyssey, which arrived on the Red Planet in 2001 and is still operating in 2022. It has returned 1 million images of the Red Planet, revealed vast amounts of liquid ice in the polar regions, and given us some information on the radiation levels on Mars. But America isn't alone in successfully landing on Mars. The European Space Agency launched a lander orbiter called Mars Express and Beagle 2. As of 2022, the orbiter remains functional, returning photos of Martian geology. It discovered Mars had long periods of flowing water and gave us mineralogy maps, which are used to understand the history of the planet. Then we have the Mars Exploration Mission, which sent 2 rovers, Spirit and Opportunity, which landed in 2004, known as one of the most successful planetary missions to have been done. Now, what it revealed was that once Mars had flowing water, a warm temperature and a thick atmosphere, suggesting that Mars was once a habitable planet like Earth. Mars Reconnaissance Orbiter began orbiting the planet in 2006. The mission has returned more data than all previous Mars missions. It identified the volume of water in Mars ice caps. Radar measurements of the North Pole ice cap found the volume of water ice in layered deposits of the ice cap was 821,000 cubic kilometers. That's 197,000 cubic miles. Mars. That's equal to 30% of Earth's Greenland ice sheet. The evidence of water was amplified by the Phoenix Mars lander, which landed on Mars in 2008. It was the first spacecraft to land on the Martian polar region. It found water ice beneath the surface and also something called perchlorate, which is found in the Atacama Desert in Chile, which is used by some microbes as an energy source, a potential sign of microbes on Mars. Then we have the ever-powerful Curiosity, which landed in the Mars Gale crater in 2012. Its mission was to find ancient habitable environments, and it was the first rover to drill into a rock on Mars. Major findings have been discovered, such as previously water-soaked areas, methane on the surface, and organic compounds in the crust, such as sulfur, oxygen, nitrogen, carbon, and other life-forming chemicals. It is still in operation. It has also found radiation levels on Mars which are similar to the radiation astronauts are exposed to on the International Space Station. And now a mission from the other side of the world, an Indian mission called MUM, the Mars Orbiter mission, which arrived in orbit in 2015, imaging the entire red planet, giving us a fresh perspective of the weather and surface. Now, Mars has a thinner atmosphere than Earth, which is what we need to mitigate when sending future settlers. But what caused it to be so thin? MAVEN, the Mars Atmosphere and Volatile Evolution, a craft which arrived in the Martian orbit in 2014 to understand why the atmosphere has thinned over billions of years. This is because of solar wind. Over time, this strips the atmosphere of Mars, causing Martian water to evaporate into space. Then we have the Mars InSight lander, which was sent to the planet in 2018 to probe the interior structure of Mars in detail for the first time, understanding how planets form and evolve. Then finally, we have my favorite mission so far, Perseverance, which landed on the red planet in 2021 in a place called the Jezero crater. Its goal is to find samples with potential signs of life in them. It will cache these samples for a future and first sample return mission to Earth. But Perseverance didn't go alone. It brought with it Ingenuity, which is why it is my favorite mission. Ingenuity is an interplanetary helicopter which proved the feasibility of flying on Mars. It accompanies Perseverance as it journeys across the harsh but wonderful terrain of the red planet. Finally, there are some notable missions I haven't mentioned, such as the Hope orbiter launched by the United Arab Emirates Space Agency in 2020 and the Tianwen-1 mission by the Chinese Space Agency. So we've landed and trundled on the red planet, we've sent a flying helicopter, discovered water, and are about to return the first Martian sample back to Earth. So we begin to have a case on settling humanity on the red planet, but how will we make it habitable? How does the planet compare to Earth? And finally, how will we train humans to live, work, and play on the red planet safely? I will tell you all in the upcoming Why Mars series that's part of Like an Astronaut. Thank you for watching. Remember to like, comment, and subscribe, and hopefully one day I will see you in space.